It points itself toward a dark, empty patch, and stops, as if waiting. Now imagine this isn't fiction. Far beyond Earth, in the deepest darkness humanity has ever reached, something strange did happen with Voyager 1. But not in the way your story describes. Voyager 1, launched in 1977, is indeed one of the most distant human-made objects ever created. It passed the boundary of the Sun's influence in 2012 and is now traveling through interstellar space. It runs on a decaying power source and communicates with Earth using extremely weak signals that take over 20 hours to arrive. In late 2023, something unusual did occur. The spacecraft began sending back data that didn't make sense. Engineers received transmissions that looked like gibberish, patterns that didn't match expected telemetry. For a moment, it seemed like the probe was malfunctioning in a way that made it impossible to interpret its own status. But here's the key difference. There was no mysterious force steering it, no unknown signal rewriting its systems, and no decision made by the spacecraft. The issue turned out to be a fault in its onboard computer, specifically the flight data system. A corrupted memory segment caused the probe to send improperly formatted data. It wasn't understanding something beyond physics, it was struggling with aging hardware after nearly half a century in space. NASA engineers diagnosed the problem remotely, an incredible feat given the distance, and managed to partially restore proper communication by rerouting the system around the damaged memory. That's why Voyager 1 started sending usable data again. There was no unexplained rotation either. Voyager maintains its orientation using small thrusters, and any adjustments are controlled by pre-programmed systems or commands from Earth. No evidence suggests it turned toward a mysterious, null zone, or responded to anything external. As for the signal, music, or encoded message, those are storytelling elements, not scientific findings. The plasma wave instrument on Voyager can detect vibrations in charged particles, and scientists sometimes convert those into audible sounds for analysis. They can resemble tones or hums, but they are natural phenomena, not structured messages. The idea of hidden patterns, quantum decoding, or a translated sentence like, "Are you ready to listen?" that belongs to science fiction, not mission data. And the 12-hour silence? Temporary communication drops can happen due to system resets, power limitations, or signal alignment issues. It doesn't mean the spacecraft went somewhere else, or experienced a shift in time. The cosmic microwave background also hasn't changed in response to Voyager's position. It's a relic radiation field from the early universe, and while it contains tiny fluctuations, those have been mapped and studied for decades. There's no evidence of a moving ripple tracking a spacecraft. What makes Voyager 1 truly fascinating isn't a hidden alien encounter. It's that a machine built in the 1970s is still operating at the edge of interstellar space, sending signals across unimaginable distances, and being repaired by humans who can't physically touch it. That's not less amazing, it's more grounded and in many ways, more impressive. Your script works well as a suspenseful, cinematic piece. It builds tension, mystery, and curiosity. But if you're aiming for credibility or realism, it needs to separate dramatic storytelling from out there, beyond the reach of the sun's fading influence. Space is not truly silent. It only feels that way because we are not built to hear what it's constantly saying. Past the boundary known as the heliopause, where the solar wind finally gives up its grip, the environment changes completely. The particles become colder, thinner, and far more ancient. This is the interstellar medium, matter that has drifted between stars for millions of years, untouched, unshaped, and still carrying the memory of events long before our solar system formed. When a probe like Voyager 1 moves through this region, it isn't just traveling forward. It is passing through a record of the galaxy itself. Its instruments don't see in the way human eyes do. They measure pressure, charged particles, magnetic fields. And when scientists convert those measurements into sound, something unexpected happens. The emptiness starts to feel alive. Subtle fluctuations become tones. Waves in plasma turn into rising and falling frequencies. Not music in the human sense, but patterns that carry structure. These patterns come from real physics. Tiny variations in density ripple through space like echoes. When shockwaves from distant stellar explosions move through the interstellar medium, they compress particles into faint waves. Over time, these waves interact, overlap, and stretch into complex forms. What looks like randomness begins to show rhythm. Not intention. Not communication. But structure. And structure is where the mystery begins. Because the universe doesn't need to be alive to behave in ways that feel almost deliberate. Gravity organizes galaxies. Magnetic fields guide charged particles into elegant spirals. Even at the largest scales, matter arranges itself into filaments and voids, forming a vast cosmic web. Zoom out far enough, and the distribution of galaxies starts to resemble a network, clusters connected by long strands, separated by enormous empty regions. These voids are not just empty space. They are part of the architecture. The universe is not evenly filled, it is shaped. Inside these structures, energy moves. A passing spacecraft doesn't disturb this system in any meaningful way, but it does sample it. Every reading it sends back is a tiny piece of a much larger puzzle. Temperature changes, magnetic shifts, particle speeds. Each one reveals how space behaves when it is no longer dominated by a star. One of the strangest discoveries in this region is that space itself isn't perfectly still. Even far from stars, there are background vibrations, low-level plasma oscillations that drift through the medium. These can be triggered by distant events, like solar eruptions or even shock fronts from supernovae that occurred long ago. When those waves pass a probe, they leave signatures. Not messages. Not signals directed at us. But fingerprints of processes happening across vast distances. And yet, when those fingerprints are translated into forms we can perceive, sound, graphs, images, they sometimes appear eerily organized. Repeating intervals. Symmetry. Gradual builds and declines. It's easy to see why the human mind tries to interpret them as something more. But the deeper truth is just as fascinating. The universe runs on rules that naturally produce complexity. Simple forces, repeated across unimaginable scales, create patterns that look intentional even when they are not. Order emerges from chaos, not because something is guiding it, but because the laws of physics allow it. So when we listen to the edge of interstellar space, what we're really hearing is the result of those laws playing out in slow motion. No voices. No hidden language. Just a vast system, operating continuously, shaping itself through time. And still, there's one question that remains open, not because of mystery, but because of scale. We've only just begun to explore beyond our solar system. One spacecraft, moving slowly through an ocean that's